Okay guys, we're going to start here with Pythagorean theorem. I know we're kind of skipping around in the notes a little bit, but we're just kind of covering what we're supposed to cover for this unit. So we're going to start here on page 2 with Pythagorean theorem. To lead off, a Pythagorean triple is a set of whole numbers that form a right triangle. You guys know by this point that anything that works in the Pythagorean theorem forms a right triangle, but we only consider them to be a triple if they are all whole numbers. So they are not going to be fractions, they're not going to be radicals, they're not going to be decimals. Every single digit will be a whole number. In this box here in the middle are just a listing of a few things that we as teachers just kind of use to create new triangles if need be. 3, 4, 5 is a very common Pythagorean triple. What it does is it allows us to take 3, 4, and 5, where 3 and 4 would be our leg lengths and 5 would be our hypotenuse, and multiply them by any constant integer and come up with an entirely new set of numbers that form us a right triangle. So remember back to your right triangles that we have two legs. So A and B would be our legs, and C would be our hypotenuse. Now, as far as our Pythagorean theorem is concerned, our A squared and our B squared, sorry, that looks like a 6, are interchangeable. It's really that C squared that has to be in that hypotenuse spot. So just make sure that as you're working through these that no matter the order of your numbers that you're given, that longest piece is always your C squared. So a few things we can do with our Pythagorean theorem, just like we did all the way back in probably 6th and 7th grade, we can use it to find a missing length. The hypotenuse of a right triangle has a length of 12. One leg has a length of 6. What's the length of the other? I would always encourage you, even on something seemingly simple like this, just to go ahead and draw yourself a picture. Make sure you get everything set up in the right order. So our hypotenuse has a length of 12. One leg has a length of 6, and we're looking for the other. So we're looking for either A squared or B squared. I tend to plug things in for B squared just because my B's look like 6's. So A squared plus 6 squared is equal to 12 squared. A squared plus 36 is equal to 144. And remember that as far as our course is concerned, we always want to keep things in simple stratical form. So when we do 144 minus 36, we end up with 108. So A squared is equal to the square root of 108. What I don't want you to do is take it over to your calculator and plug in the square root of 108. 10.4 is not wrong, but if I give you a leg length of 10.4 and a leg length of 6, you won't get that 12 back for the hypotenuse. So remember that whenever we are simplifying radicals, we want to split this thing up. Always look for common factors. I know that 108 is divisible by 2, so I've got 54 and 2. 54 is 9 times 6. I have 3 times 3, and 6 is 3 times 2. If you guys remember, my philosophy on these is to circle pairs of numbers and box in the loners. So 2 leave the house and become 1, so I'm going to bring out a 3 and a 2 in the form of a 6. And leave behind my loner of a 3. We'll kind of recap simplifying those here in just a minute. A triangle has side lengths of 16, 48, and 50. Is the triangle a right triangle? So if I split all these up here in my diagram, remember that regardless of the order, always make sure that that longest side is your hypotenuse. So I've got 16 and 48. Ideally, if this is a right triangle, than when I do 16 squared plus 48 squared. That will give me 50 squared. One of the easier ways that I do this is that if I take 50 squared and I subtract away the two of them, then if this is 0, then our sides balance out and we have a right triangle. So I'm going to come over here to my calculator. 50 squared minus 16 squared minus 48 squared, and I end up with a negative 60. So this is not a right triangle because a squared plus b squared does not equal c squared. That is enough of an explanation for what we're going to be doing. If we're asked, like we are on number 3, to find a third whole number so that the three numbers form a Pythagorean triple, we are looking for, remember, that third number that is an integer. So we're going to run ourselves through two scenarios here. Our first scenario is that we have c squared. And our second scenario is that we don't have c squared. So if I have c squared, 21 has got to be it. So I'm going to put over here a squared plus 20 squared is equal to 21 squared. And I'm going to solve this for that a value. And if a is an integer, then I have myself a new triple. So I'm going to go ahead and work through this. A squared is equal to 21 squared minus 20 squared. 21 squared is 20 squared. So a squared is equal to 41. 41 is not a perfect square, so even though the square root of 41 would work, it's not going to form us a triple because it's not an integer. So I'm going to move over to number 2. Let's pretend that we don't have c squared. So that tells us that 20 and 21 are our a and b. So I'm going to start out here with 20 squared plus 21 squared is equal to c squared. And 20 squared, if I can type this in right, 20 squared plus 21 squared is 841. And then when I take the square root of both of those, let's see, trying to get used to Desmos here. The square root of 841 is 29. So I have 29 is equal to c. So what that tells me is that 20, 21, and 29 is a Pythagorean triple. And then when I move over here to this other one, I'm going to kind of separate those out a little bit. We're going to run through the same setup. So option number 1 is that we have c squared. In this case, it would have to be the 48. So a squared plus 14 squared is equal to 48 squared. I'm going to come over here. 48 squared minus 14 squared gives me an a squared that's equal to 2108. I do not know what the square root of that is, but there's an easy way to find it out. So square root of 2108. So a is going to have a value of 45.9-ish, which is great. It'll work, but it's not what we're looking for. So scenario number 2 is that we need our c squared. So I'm going to have 14 squared plus 48 squared is equal to c squared. 14 squared plus 48 squared. This is 2500. And when I take the square root of both sides, 50 is going to be equal to c. So I have 14 48, and 50, which if you divide all of those by 2, that's that 7, 24, 25 right triangle triple that you see up above in our box here. Now, a couple of things that I want to do before we move on and finish out today is I want to work with simplifying some radicals. So I just kind of came up with some examples over here on the side. Remember that whenever we are simplifying, the first thing that we've got to do is split this up into our factor tree. It doesn't matter how you split it up. You could start with 12 and 4, you could start with 8 and 6, but it should all narrow down to the same exact prime factorization. So I'm going to go ahead and start out with 4 and 12, 2 times 2, and let's see, 4 times 3. I've got another set here of 2's, and I like to mark out what's gone. So I have a pair of 2's, a pair of 2's, and a single 3. So 2 2's, one from each set, is going to leave the house, and my 3 is going to stay put. So 4 square root 3 would be how this simplifies down. If I have something like the square root of 65, then I'm going to have, 5 times 13. Both of those are prime, so nobody leaves. Everybody's stuck. Everybody has to stay home. Kind of like us right now, I guess, huh? The other thing that I want to talk about is what happens whenever we square a square root. A lot of times it doesn't really matter for you guys as long as you see like the square root of 4 squared. You guys know that those are inverse operations. It ends up being the square root of 16, which just simplifies down to 4. It breaks free. But where you tend to have an issue, especially whenever you're dealing with a calculator, is whenever you have this entire quantity that is squared. So we're just going to play around. We're going to go ahead and plug this in. 3 squared plus, put this piece in parentheses, square root, parentheses 3 square root 2, end it, and then square it, is equal to x squared or c squared, whichever you prefer. The reason being, if you plug 3 square root 2 squared into your calculator, this is going to say, hey, take 3 times the square root of 2 squared, and it's going to limit you to this. But we want to square everything. So I'm going to have 9 plus, this square is going to distribute itself to both pieces. So this ends up 9 times 2, which is 18. 9 and 18 gives me 27. And let's keep going here. I'm going to go ahead and split this up. This is 9 times 3, 3 times 3. I'm going to bring out a 3 and leave a 3. So x squared is going to be 3 square root 3. Always put that quantity in parentheses. I added an extra page here just so that we could do a couple more examples before we go for today. So I've got this set up here. I need x, and I cannot ever assume that this up here is 90 degrees unless it's marked with a right triangle, as a right triangle with a little square. So no matter if it looks like a right triangle or not, if that's not there, don't make that assumption. So the first thing that we're going to need to find is this bridge here in the middle. I have 6 as my c squared, so I'm going to go ahead and set that up as 3 squared plus b squared is equal to 6 squared. Let's see, 9 plus b squared is equal to 36. So b squared, if I take 36 minus 9, because my brain's not working, is 27, and I did that up above, so b is going to be equal to 3 square root 3. And those tick marks tell us that this one over here is also 3 root 3. And now I'm focused on this triangle on the right, so I'm going to scoot it over. Remember, put those two in parentheses. So 3 square root 3, quantity squared, plus 3 square root 3, quantity squared, is equal to x squared. This 2 distributes itself in, so this is going to be 9 times 3, which is 27. So I've got 54 is equal to x squared. And when I take the square root of both of those, this is 9 times 6, 3 times 3, and 3 times 2. So I have a pair of 3's. Both of these guys stay. So I have 3 square root 6 as my c value. And then last one here, I want to find the c squared. So I've got 2 squared plus 4 squared is equal to x squared. And 4 plus 16 equals x squared. Keep going. And simplify. 4 times 5. Bring out your 2's. Loner 5 stays home.